I'm Sandro Hawk, one of those W3C staffers they mentioned. Can you hear me in the back okay? Okay. My name is Sandro Hawk. I've been at W3C for just about forever, coming up on 15 years now. And normally I was going to give a bit of an introduction to W3C, but you've had a ton of that in the keynote this morning, so I don't need to do that. But I do want to sort of distinguish that most of W3C and what was talked about this morning was all member-driven standardization work. But we also do some research, which is not funded by members, but instead funded by research grants, and that's what I'm talking about here. So this is not standards work exactly, but it feeds into standards work. So I participate in LDP as a researcher rather than as a W3C representative. So it's a little confusing with the two hats. And I definitely want to thank some of our funders here, which is the Knight Foundation, Qatar Foundation, National Science Foundation, and MacArthur Foundation, all of which are funding bits and pieces of this. Also, one of my collaborators, Andre Sommer, is in the front row here, and feel free to talk to either of us afterwards. So I want to talk about social software. And we hear the word social all the time, and I think people have different ideas about what it means, social media, etc. I have a, I think, very simple definition here, which is social software is when the value comes from the other users. So it always has the feature that if you use a piece of social software for the first time without other users there, it feels like a ghost town. There's no particular value. It's not useful to you because you're the only one there. So I've just sort of brain dumped a bunch of ones that came to my mind here. There's so many more. Practically everything that makes the news in computers for the last 10, 15 years is social. I mean, Twitter without anyone else on the system, that's going to be really useful. Or a dating site without anyone else on the system. Or an invitation site. None of these things make any sense or have any value without other people. But of course, they're all incredibly useful when there's other people there. Your friends, your colleagues, strangers, depending on what the kind of site is. So I want to build social software in LDP, and I'll explain why as this sort of comes full circle. LDP makes a great platform for social because it's very simple and straightforward. I mean, if you were in Arnaud's talk, it maybe seemed complicated because he was trying to put a big thing into 45 minutes. But actually, compared to other technologies that perform the same kinds of data management features, it's dirt simple. It's really much simpler than many of the alternatives. So that's great. It's not quite complicated and powerful enough for what I need for what we're building here. So really, we're using LDP 1.0 as being standardized, plus a whole bunch of extensions. Those extensions we will be feeding back into the standards track. So LDP 1.1, 1.2, maybe 2.0 at some point should be able to do all the things that we're envisioning here. And if you're interested in that, by all means, join those working groups as they happen. So what we're building here, we call it Crosscloud, and the idea is that Crosscloud is a system that ends social lock-in. When you're using Crosscloud, you're not ever in a ghost town because all the different apps that operate in the same space share data under the hood. So you can easily move between vendors and between different kinds of social software. And I'll walk you through this. Why is this important? Why would we want to be able to move around? I mean, some of us feel this intuitively. Maybe everyone in the room feels it intuitively, but let me just sort of go through the list for a minute. Users would like to be able to move around. Right now, privacy is a really big buzzword, right? We see how Facebook most notoriously, but pretty much all of these sites, their business model is mining user data. And users are feeling really grumpy about that. But they have no choice because their grandparents are on Facebook, so they have to share the baby photos on Facebook. Whatever it is, they have to be where the people are. And with Crosscloud, they would have mobility to move to a different site that has different privacy policies, different business models. Security is a little different from privacy. Security is not that the company is mining your data, but they're not protecting it well enough. So we'd like to give people a choice to go to alternative software that has better security. You'd like to be able to reach everyone online. Right now, certain friends, certain colleagues use certain systems, and maybe you can keep track of that. Maybe you can reach some of them. Maybe you post to 9 different systems using some software that helps you do that. It's kind of ridiculous. And some people won't be signed up with any of those. You'll never reach them. within my different work groups that I'm a part of, there's no one system I could use to facilitate that particular group, because somebody won't use Facebook, somebody won't use LinkedIn, somebody won't use each of these things. So to be able to reach everybody by a system that is interoperable across all of those seems like a great vision. I mentioned privacy goes away because of data mining, and that's because of business models. So to have the option to self-pay. I would happily pay $3 a month or $7 a month or something to be able to use these systems and not see ads. Someone else may want to see ads, that's fine, that's their choice. To be able to use the same tools across different communities and different tasks. So I have a to-do list at work, I have a to-do list at home. Maybe my employer is careful about making sure my work to-do list lives on their servers under their protection, so I then can't use the same software between the two, which is a pain. No reason not to open that up if we could make all the protocols work right. And just in general, by allowing openness, by allowing migration, we support innovation. If you want to give something better than Facebook, too bad. You can't get the users to switch from Facebook to your system as it is. With Crosscloud, the idea is people can move between vendors easily, so if there's a thing that's a little bit better, people can start to move and use it immediately. So we think that fosters innovation quite dramatically. So for users, that's a list of benefits. For application developers, I see three main benefits. The first, I touched on a moment ago, is the avoiding a ghost town. You make something that's better than some existing bit of social software, and you can get people immediately. The value is there immediately because you're sharing all the data from the other sites. There's also, because we envision data hosting providers to exist as their own business, there's no need for back-end operations for an application. You write a bit of code, again, I'll walk through this in a minute. You write a bit of code, you publish it on the web, and everybody can use it. Millions of people can use it, and you don't even need any staff sitting by managing their data, any responsibility for maintaining the security and privacy of their data. You just provide the code, kind of like the old days. And finally, having your users be your customers so you can respect them and treat them well, I think is a big win. Again, in the current business model, usually your users are a product that you package for your advertisers. And I think a lot of people have resentment against that and wish that's not how the world works. So this enables us to go to the place where your users are actually the people who pay you for the value. So how does all this work? I've said a lot of benefits. Most people I tell this to say, that sounds awesome. How could you possibly do this? And the basic idea is that you separate the data from the software. I mean, this is an old story. DBMS did this a long time ago. In the business context, we're doing it in a personal context. So just to run through one more little sort of example here, we have Alice and Bob who are trying to schedule a meeting. There's lots of different meeting scheduling systems out there. Doodle seems to be the one in my community that's catching on, but different ones of these, maybe some of these have gone out of business since I made this slide, but when I made this slide, these were some of the leaders in the market. And the story we all know is that Alice and Bob have to both go to Doodle if they want to schedule a meeting together. And so you end up with this sort of almost monopoly going on there. And in contrast with Crosscloud, let me go back for a second, notice that we have database icons next to each brand, because each one has its data, stores all the data, what the meeting scheduling preference, what Alice's meeting scheduling preferences end up at Doodle, and Bob's have to go there too for the match to be made. With Crosscloud, each person has their own database, and their preferences live in their database. And all those same products can exist out there, but they exist as just software that reads and writes the user's data. So that Alice can be using Meeting Wizard here on her handheld and Doodle on her laptop, and Bob can use different ones. And as long as they are compatible in the sort of straightforward ways, they should have interoperability. So I'm going to go now. That was all very abstract and hopefully motivating. It made this all sound really cool. I want to talk about a much more concrete example, something we built. Actually, Andre wrote it. It's being worked on now by students, but he wrote it earlier this year. Something called Simba, which is a demo or flagship for this. And what Simba's trying to be is Twitter circa 2009, back when it was catching on like wildfire, before they had to add all sorts of cool features, but it was really enough. Everybody loved it, in the media in particular in those days. And we want to show that we can do that kind of functionality in a decentralized way with everyone, with all the advantages I've covered already. Simba stands for Client Integrated Microblogging Application. So it's kind of like blogging. Everybody has their own stuff, but it's all integrated in the client so that it provides the user experience people know from Twitter. You fire it up, you see what everyone else is posting. We'll do a demo in a minute, I hope. So I'm going to walk through how Simba works, and just keep in mind that this could work for a lot of other things. Some of the other applications we're most excited about right now are personal health tracking. People exercise and want to share with their buddies how they're exercising. I don't like doing that, but I know a lot of people do like doing that. Issue tracking, bug reports, group software development or other kinds of projects. Expert networks. This is pretty exciting in the eGov community right now, people finding other experts in the same subject area. LinkedIn kind of does this, but a decentralized one, not built on LinkedIn, and more extensible to more specific expertise areas. Sharing camera output. Everybody has more and more cameras that can do more and more things, and there's a ton of data there, how to possibly manage that, share it with the people you want, privacy you want. Meeting scheduling, meeting agenda, meeting management is a great one, and buying and selling is actually important. That's right now still very in narrow controlled areas. So how does Simba work? Everyone knows how Twitter works, I think. People tweet, and other people who follow them see those tweets. So mapping that to LDP, when you tweet, you're doing a post to a thing we'll call your channel. It's an LDP basic container. It's a web resource that stores a bunch of data, and you take your tweet and you post it. And I'll show the exact protocol in just a minute here. To see what the tweets are, you do a get on the channel, and you'll get a list of all the different tweets that have been there, and then you follow each of those links for more details. It's really very simple. So we start with Alice. She's changed her hairstyle now. Alice goes to Simba.co and downloads some HTML and CSS and JavaScript. She never writes back to Simba.co. Simba.co has no idea what she posts and no control over it. It's just a static site. She could download that to her hard drive and run it from there just as well. Bob does the same thing. He grew a beard since our last slide. He downloads the same code, or maybe he downloads some other code. It could be modified. He could download it and change the styling, change various things, as long as it's using the same vocabulary. Anytime they want to write something, subscribe, post something, it goes to their pod, their space. Sometimes we call it a pod. It's basically LDP space with the extensions we've talked about. When they want to get stuff, they read it from their own pod or the other people's pods. And this is just an HTTP. So it was an HTTP post or put or patch as LDP specifies. So send the stuff, and it's the stuff in green as they do normal HTTP get. To get it, we're in this process of exploring changing over to a protocol that's more like this, where you only ever get from your own pod, and your pod does the get from other people, because that way we can do more caching and we can get higher performance and address some security issues better. Conceptually, either one works, but with the demo is based on this style. We're switching over to this style, I think. Another set of protocols we need is notification when things change, and something called web mention, which is the latest version of sort of trackback to see when people talk about you. That is currently entering standardization within the social web working group, which has their first official meeting next week. Plug. So yeah, so that's a little complicated when you look at it like that, but each of the pieces is really straightforward HTTP operations and normal web app style. So what do the actual details look like there? When you want to do a post.
Sorry, Sandra.
Yeah.
Are you going to cover how Alice knows that Bob exists?
We'll see how I do on time.
Okay.
So digging into the post for a minute. So she's going to do a post. So she has, I don't think my laser pointer will work. Nope, it's too dim. No. Okay, so she, her host Alice.com is her own host. She's going to post some turtle to it. She's going to post to her channel, this shared MB CH1, channel 1. We have this idea of having multiple channels per user where Twitter only has one, but it doesn't really matter for these purposes. So anyway, there is this URL that represents her channel, and she does a post to it, and she posts really straightforward. This is a shocked post. It has shocked content below world, has a creation date, and she's the owner. And the server, her LDP, responds to a one created, and it created entry 5 in there. The server assigns a new URL for the particular post. This is so simple to a web developer. We're throwing turtle at it instead of JSON or an HTML form or whatever. It's the normal thing. You post and you get a new thing back. And if you do a get, it's exactly what you expect. We do a get on the channel. We ask for turtle, and we get back. This is an LDP basic container. It's got maybe basically the title of her blog, Alice's Thoughts. And then all the things in the container. And in this case, let's say she made 1, 2, 3. She made 4, deleted it, and now she just did 5. So we get back those 4 posts. We'll do a get on 5, the one we just posted, and we get back exactly the same content as we posted before. In fact, it could be the same bytes, or it could be loaded into a database and reserialized in completely different bytes, but the same basic triples, the same thing. If this is a post, here's the content, and so forth. It's almost just like a network file system. It's just really quite simple. Okay, so that sort of is all we need to do the basic demo, and then there's a bunch of more sophisticated things, which I'm going to talk about each one a little bit here. One is identifying users. So as you can imagine, we're using IRIs to identify users, and you dereference them to get information about the user. So Alice, in this case, might be identified by alice.com/profile #me, something like that. We don't really care what kind of URL or IRI that is. I personally like using just URLs. But in our current code, we're using these IRIs. In any case, when you do a get on that, you get back stuff about her, an image of her and her name, maybe some things that help with authentication. I think this was your question, David, which is, how do you find the user's channels? How does Alice find Bob? So, no, this isn't that question. This is how, when the client starts up, how does it boot up and get the information? So assuming it has the person's URL, their web ID, it has to do a get on that and then follow a bunch of links before it actually finds their channel. And we have a kind of complicated story about how this works because there's a bunch of issues about different apps writing in different spaces for different reasons and trust. And I don't know that we've got this 100% right. But this is what we've got working right now, which is you get the web ID. At that place, there's a link called storage : that goes to somewhere where there's a channel space, and then within that, there's a channel. And this is a diagram of, I don't really need to walk through it, but it seems to work.
So the bottom line is, if my software, my machine wants to talk to you, regardless of what you're using, what the details are, what I need is your URL to your web ID.
Yeah.
And I'm done.
Yeah.
That makes a lot of sense.
Yeah. So authentication. How does that code that came from Simba.co get permission to write to Alice.com? That we're currently using WebID TLS. There's a couple other ways we could do that. WebID TLS is the idea that it's a public-private key using the existing client certificate system in browsers. So basically, the public key is in your WebID, is in your profile, and then anyone who's got the private key for that can prove that's them. This works. It's very secure. Unfortunately, the current browser vendors provide a user experience. The user interface for client certificates is really problematic. And they've left it untouched for years and years, and we're not getting a lot of promise that they're going to make that better, so we may have to explore some other options here. But we can totally do that. That's not built into the architecture that we do this. It's just how we're solving it today. With that, I'm going to try running a demo video rather than doing a live. There'd be too much switching between users for me to do this live. Let's see if this works. It's about 3 minutes.
Like many applications, Simba begins by asking the user to log in or sign up. In our example, the user Alice signs up with a new account. This is not a Simba account she's getting though. It's a general purpose data storage account on any compatible data storage service. There's a drop-down box where she can pick from one of the services currently running. The service she picks is one that doesn't use passwords for users, but instead uses client SSL certificates. Here we see one being generated in her browser, and then her selecting it for use by Simba. Now Simba's going to ask her a couple questions about how she wants her data to be stored. A more polished app might just choose for her, but for now we want to make it clear that the data is under her control. She's just picked the name for her microblog, and then she's going to be picking the name for her first channel. She's just going to call it main. When she creates this channel, she'll choose whether to make it public or private. In this case, she makes it public. Now Alice can make her first post. Wow, this is great, she says. I guess she likes answering all those questions. Once she clicks post, her test is made available on her data server. Now let's go to Bob. Bob doesn't use Simba. He uses a different Crosscloud microblog now. He uses the same standards as Simba, so it's interoperable. Here we see his screen with microblog posts from several different people he follows. His friend Alice has just told him that she's got a microblog and he's going to subscribe to her posts. He enters her web ID and then selects her main channel, the only channel so far, to subscribe. Immediately, Alice's posts appear on Bob's screen in time order. Now Bob's going to send her a message. Let's see what he says. Hi, Alice. Nice to see you here, too. When he clicks post, all of his subscribers will see it. Alice isn't one of his subscribers yet, though. She won't see that message until she subscribes to his channel. She's going to do that now. She'll select channels and enter Bob's web ID. Soon we'll add some features to make this part easier, so she won't need to even see his web ID. Now that she's entered it, she sees his list of channels. She subscribes to both, and immediately his posts appear in time order. Right on top is his greeting to her. Now that they've subscribed to each other, they'll see each other's messages right away.
Phil, I don't think I know how to get back to the slides.
Awesome time, dude.
Okay, great. These slides are on the conference website, and there's links to Simba, and just Simba.co basically funds you everything you need to. So if you want to play with this. So that was weak in a couple ways. I mean, it basically works, but it had some problems. So let me talk about some of the things we want to add and change going forward. I talked about how we want to change to going pod-to-pod communication instead of going to each one, and that will solve this client cert pop-up problem. We're doing this with what we call link following Sparkle, which there could be a whole talk just about that, so I'll just do sort of a placeholder. It's the idea that rather than sending a Sparkle query to a Sparkle engine that runs the query against the data it has, you send it to a Sparkle engine that has no data at all, and it just looks at the URLs in your query and dereferences those, pulls those in, binds some search results, binds some variables based on what it pulled in. Now it has some more URLs, and it can pull in more stuff. And we find you can basically write a Sparkle query that acts as if everything on the semantic web were in one database. I mean, often you can do this. A few other people have experimented with that. That's what we're trying to use in our pods, so that you just do a query to your pod, and it goes out and queries all the other pods as necessary, and other RDF data sources, not necessarily cross-cloud pods. So that's one thing we want to do next. Search, and this is what David's question was, which is how do you find people and channels and postings if you're not already finding them, subscribing them. You don't have their URL. And in general, this probably needs some kind of a global index. There's two different things here. There's search where you have no social connection whatsoever to it. Like you hear an ad on the telly saying, come look up this thing, and they don't give you a URL. You're supposed to use some keywords. And so that means this really global search. And that requires something like a search engine. And from our perspective, right now, we have a plug-in thing where we can have multiple search engines at the same time. So it's not terribly centralized because there's many of them and no particular one gets any great power. Some of our collaborators at Southampton want to do this in a DHT style. So it uses some pretty clever ways to not need any central servers. We're not banking on that, but that may pan out, right? The other kind of search is social search, which is, I think, probably 99% of the time you want something, probably one of your friends or friends of friends or friends of friends actually has some information about it already. So in fact, just by having your pod sort of wander out a little bit on your social network, in fact, most of your searches can be handled that way. And that's definitely an open question, which of those will pan out and what technology. We're trying to keep our options open there. So Alice can find Bob's URL either because they have some friends in common or she's using some kind of a search engine, assuming he didn't give it to her directly. And the third area that we're definitely working on is notifications. I mentioned web mention, which is beginning standards track, and in general, some way to tell that website content has changed. People have proposed things like this many times over the years. We need to pick one and get that into the standards track. You want to know when you've got a new subscriber or a new reply, things like that. So that's Simba. Let me generalize to other kinds of software for a minute. So for instance, playing chess. Let's say Alice and Bob are playing chess, just to make sure we understand these ideas. So Alice posts her moves to an LDP basic container instead of her tweets. And Bob does the same, and because they link to each other, as soon as you have a URL for any of these things, you can write a Sparkle query and get the whole chess game. And anybody can watch it who has permission to watch it. I've skipped a bit here that, of course, anyone who controls these servers can control the access control lists and say who's allowed to see what. So they might be playing a chess game where only Alice and Bob can see each other's games, or they might each other's moves, or they might be playing a public game people can watch. And Simba implements this. When you do a post on Simba, you can make your post public or private or to a group. So going back to our list of applications we're excited about, for personal health tracking, you basically just, an obvious extension of Simba, you just post descriptions of what you've done, but not as plain text. You can use whatever RDF vocabulary you want to model the activities you've done in exercise, and then people can run queries across those among their social group or people they have links to. For issue tracking, you post new issues or comments on issues, you patch to do status updates, and you query to see the state of the universe. An expert network is basically just profiles with embedded RDF, so that doesn't even need a lot of this technology. A friend cam or some sort of video and photo sharing thing. This uses the LDP feature that you can also post binary data. You don't only post RDF, you can post JPEGs and MP4 files and whatever you want. And the servers can handle that just as well and handle all the metadata around it. So the basics are, I think, really very simple. When something happens in the app that it wants to record, you post new things, or you patch things. To get the state of the world at sort of a very specific low level, if you know exactly the resource you want to find out about, you do a get. If you don't know that exactly, and you sort of want to find it everywhere, you do a link following query. Everything obviously is dereferenceable. Everything's identifiable by dereferenceable identifier, URL. Access controls are always available. We use backlinks and notification to tie the pieces together. So next steps. Linked Data Platform provides many of these pieces. Arnaud already made this pitch. Please try implementing LDP if this is at all interesting to you. It's really very easy to implement at least basic containers. We don't even need direct containers and indirect containers for what we're doing. So that makes your implementation somewhat simpler. There's a mailing list to talk about this, public LDP. Probably not much point in joining the working group at this point because it's wrapping up, but consider joining the next round of the working group. Meanwhile, the social web working group, which is doing, for instance, web mention and maybe some other pieces here, is just starting up. Great time to join that group. Meetings are Tuesday at 10 a.m. Pacific time. This was set last night, so I just modified the slide this morning. You can try Simba. There's a Crosscloud announced mailing list where we'll send something every couple months with our status. And talk to me, talk to Andre. That's it for my slides. I have almost 10 minutes for questions, or we can go to lunch. Greg?
Yeah, the channel. There's some notion of type associated with the channel, so when I post something to a channel, I know what it expects. For instance, you should put the message, which should have text content, perhaps it's associated with some form of a statement on the work type. Is there some broadcast mechanism so that a client knows what the storage service is expecting to receive from that channel?
So the storage service is completely agnostic to the application. It knows nothing about Simba or microblogging. It just takes these posts of content. So in that sense, it doesn't care. So what you need is interoperability between the different clients. And obviously, Simba is going to interoperate with Simba. And there's a question as to how you document that these are the, basically, this is the vocabulary that Simba reads, this is the vocabulary Simba writes. And there's an ongoing process here that we need to figure out exactly how the community does this. The data shapes working group, which will hopefully be starting up soon, I think is going to play into that as a way to document. This is the data shape we write. We're always going to write data of roughly this shape. And we're always going to look for data of roughly this shape. If you want to interoperate with us, you have to play that game.
It's also a Hydra use case.
Yeah, Hydra is very much in this space, for sure. Yeah, I'm sorry, go first.
I have to say, I love the idea. I think it's a problem worth solving. Technologies and suggestions that have gone down this route have always ended up seeming to be a little bit lacking because of this idea that my mum might have some kind of URL that identifies her and some kind of space to store data. And so I wonder if you have thought about that at all. And obviously, you seem to be using some providers who will provide people with those kind of spaces. But then are we just shifting the problem from Facebook owning my data to one of those containers owning my data?
So it's a great question. Several answers. The first is that I didn't go into how, but we believe we can make it so you're never locked into those providers. So if you become unhappy with them, you can switch to a different one. So as long as there's some kind of a market, many different pod provider options.
Would that rely on me having a URL space that I control?
So there's several different possibilities here. One is, of course, you can get your own domain name. That would give you this. We don't actually believe people are going to get their own domain names. Yeah. Another option is to have people get their own subdomain name, which is provided by the provider with some kinds of guarantees about portability. Which is, so I get a sandro.rww.io, and they, before I choose that, they promise that I can always have, they'll repoint the DNS to that, to any other provider I want. And we could make that some kind of standard in the protocol that you have to do that. A third option that we're just exploring very recently, which I personally like, is to allow, because we've got the backlinks of who's mentioning what, we can feed out a please change and rewrite all the data sources that were pointed to this to point to somewhere else. I don't know if that will actually scale enough, but I think that would be pretty fun. Another higher level difference, so I think pod providers, big industrial pod providers will probably be how this works, but other people seem to think that handheld things that you plug into your basement or something will be very popular. In particular, there's sort of legal protections that apply if it's in your house in the United States that don't apply if it's outside of your house. So maybe some of each, right? Things need to be more available and you care less about the privacy you put in a pod provider. The other thing is you go to Best Buy and buy something you plug in your basement for a different level of privacy.
I would buy something that plugs into my basement. Like it's
So, you know, I really like the idea of people owning their own data, having that separate from the apps. A few years ago, there was this, actually a speaker at one of these conferences, I think his name was Siegel, who talked about pull and personal data lockers. So I kind of see this as sort of a concrete implementation, standards-based implementation of that concept.
Obviously, many of these ideas have been batting around for a long, long time. And there's other people right now trying very hard to make it reality too. And IndieWeb does this from a more blogging perspective, less app perspective. There's several other folks trying to do this. And before this all gets standardized, hopefully we'll all converge and all agree on how to make the details work. Ryan?
So we've been looking at this problem a lot about data portability.
Yeah.
When it comes to it's really centered around payments and credentials and things like that. And I think the conclusion we've come to is that it's not going to be possible based on the protocols that we have today. We're going to have to create a new protocol to give people some kind of identifier that is portable, right? Because if you think of it, the URL is this great lock-in mechanism. The second you have a URL to your personal data, if you have anybody else digitally sign that information, you are locked into that service for the rest of the usefulness of that credentials life, right? So think of the U.S. government assigning a digital social security card to you. The second they digitally sign that, you cannot shift providers. So the URL that you tie that information to has to be ultimately portable. And that's one of the things that we've been grappling with, is that I don't think for easy use cases, yeah, you can set up a data provider and you can tell, give a message to the network that they need to rewrite all the data because you've moved from provider A to provider B. But that doesn't scale, I don't think, to some of the more serious use cases.
You're certainly right that signing data makes the rewriting pointers much harder. I mean, I think that the second option I gave, the subdomain portability, probably will work. I mean, I know some universities now are providing portable subdomains to their alumni, and I think that's a great kind of model. And I think as soon as the expectation gets out there that when I sign up for a service at some payment level or some commitment, it's their responsibility to provide a portable subdomain from then on out. I think that's economically doable.
I'm not convinced that that's going to work, and
Yep.
I think W3C should really look into a decentralized identifier protocol. It's inevitable. I don't think that this is something that I think yes.
And let me be clear at that point. You came in late. That I'm wearing my researcher hat here, not my W3C hat. So by all means, W3C should look in that, and I'm happy to participate in that and help with that to the extent I can. And obviously, I just want the problem solved, like you, and whatever we can work out would be awesome. David?
So when I look at this, positively and with the open OCC, it looks to me like what NNTP might have been if the web and link data had been around back then, right? We had a nice distributed system for some of this sort of thing before the web. And I would, without really looking into it deeply, I would think that NNTP didn't survive the advent of the web primarily because even though it worked for geeks, for us, everybody's mom really wanted to just jump on Facebook because that's where the users were, that's where the ease of use was, etc. So I do feel that users jettison privacy and security for convenience on a routine basis, and I'm mildly discomforted by the presumptions, some of which are stated and some of which might not be. I really just, I'm wondering if I can try to put this into a question form. What are the presumptions that you think are here? You've said a couple of them, but can you really just kind of lay out where your thoughts have gone about what infrastructure needs to be there, what kind of things have to be present for this to really work?
Technically, that's the end of our time. Let me try to answer that for a minute. I mean, on the sort of people choosing one thing or another, choosing convenience. So I put privacy first on this list. I don't actually think that's what's going to get people to change. I think some people will. I mean, the main thing is different people have different motivations, and some people will never be motivated by privacy concerns. Some people will be motivated the instant this is available for privacy concerns. For me, I think the sort of last one, the quality and innovation. You know, I think the cool new apps that are hard to even imagine right now are going to grow a lot faster in this growth medium than the old style or the current growth medium, and so people will switch. Whatever it is, I can't even imagine what it will be. Will end up being based on this. So it'll pull the users along because the cool apps are there. The other part of your question about sort of what exactly do we need, I'm not sure I can enumerate that here and now.
Well, you mentioned the search engine.
Right.
For example, you mentioned without being explicit about it, a web ID provider. Those are the kind of presumptions I'm talking about.
Yeah. That's too long a list for me to enumerate right now. We have some stuff on the web, and I'm happy to talk to you more.
I'll read it and talk to you.
Okay. One last quick question? If not, I gather we're on our own for lunch. There's restaurants in the area.